Hello, welcome to the course in real analysis. In this particular course, we are going to study real analysis in R. In this particular course, we are going to first start with real number system, a very basic of real number system. Then we'll go on to some basic topology, some tools that are required for doing real analysis. Then we're going to continue with limits, continuity, and differentiability. And then we'll end this particular basic course at integrals. This particular course is designed mainly for students who are preparing for MSc entrances. This may be helpful for people who are entering into PhDs or probably giving their post-PhD, post-MSc exam like NET, GATE, or exams like this. Okay, so I hope you'll enjoy this particular course. In this particular course, the methodology will be more of, you can say, of doing questions and learning things. Wherever required, I will give you proofs. Otherwise, I will give you the uh, reference of the book that you should be referring for this particular course. Okay, so I think this is an introductory thing that I wanted to speak. The books I would refer for people who are in BSc, that is Bachelor's of Sciences. If they are acquainted, if they are more acquainted with Indian authors, then they can follow Shanti Narayana by Eastern Publications. They can also go through another book called as S.K. Mappa. I'm not very sure. The author is called as S.K. Mappa. Another one is S.C. Malik and Arun, if I'm not wrong. And these are three leading Indian author book on real analysis that you may get. For people who are very who can who are this who have this understanding of foreign authors can pursue Bart and Sherwood, or you can also go through understanding analysis by Stephen Watt. So I think all these said and done, what my strategy would be, see, why I'm focusing mainly on the exams which happen after your BSc, that is and exam and you can say TAFR. Obviously, this particular course is also useful for any general audience who is pursuing BSc, honors in mathematics or mathematics. In general, any mathematics aspirant can, any mathematics enthusiast can also see this course. And you will enjoy this particular journey. So let us begin our journey with real number system. As you know, real numbers can either be in two varieties. One can be rational, another can be irrational. Okay, so what are rational numbers and what are irrational numbers? This is our first thing that we should understand, because the title itself is real analysis. Real number, rational numbers and irrational numbers. Okay, so understand the fact that rational numbers are those numbers which can be expressed in form of P over Q, such that the GCD of P and Q is 1. That is, we can reduce them to the lowest terms. When reduced to the lowest term, the GCD of P and Q should come as 1. Or in terms of decimal representation, their decimal representation should be either terminating. For example, 3 over 4, the terminating decimal representation is 0.75. Or even if in case it is non-terminating, then it should be periodic. So for example, I will give you an example and let you understand this thing. So if non-periodic, let's say 0.1 by 3. So it is 0.3333, so on and so forth. Okay, what are irrational numbers then? So irrational numbers are those numbers which cannot be expressed in form of P by Q. Which cannot be expressed in the form of P over Q, or when talked about their decimal representation, the decimal representation will be non-terminating, but it will be aperiodic. So the decimal representation would be aperiodic. By aperiodic, I mean there would be no certain patterns of numbers repeated after the decimal. Okay, so these are the two wide categories which bifurcate your real number system. So you have these rational numbers and you have these irrational numbers. Okay, Now you see, further, what do you think that how to think about okay, so let me slightly get into irrational numbers. So what if you remember from your childhood, some examples for irrational numbers can be what? Root over 2, can be pi, can be e, etc. And in the due course, we will prove all of these to be irrational. Like pi, I'm going to prove later on. E, I'm going to prove after the series is done. Root 2, I'm going to prove today. Okay, so let us take examples and let us understand how to prove irrationality. So how to prove irrationality is today's small topic of discussion. How to prove irrationality. So let us prove the irrationality of, let's say, root 2 at first. So let us start with proving the irrationality of root 2. So I'm just writing this. Proof that root 2 is an irrational. Okay, so if one says that root 2 is root 2 is an irrational number, how to go about it? So I'll come to all these strategies of proof also later on. But since I assume that you are in BSc, so you must be knowing something called as proof by contradiction. Okay, so it is one of the proving techniques in mathematics. So let us prove that root 2 is an irrational number at first. At first, let us start with this. Okay, so in order to prove root 2 is an irrational number, how do we start? We start from assuming that, let us say that root 2 is a non-rational. Let us assume that. Let us assume that root 2 is a rational. Let us assume that root 2 is a rational. And if root 2 is a rational number, then what will happen? Root 2 can be written as p over q. Root 2 can be written as p over q. And if root 2 can be written as p over q, such that p and q, the GCD is 1, that is p and q are co-prime to each other, then one must remember that if I do a square on both ends, what I'll get? I'll get 2 times q square is equals to p square. So I'll get 2 times q square is equal to p square. This is one thing that I will get. Also, one can think that if p square is equal to 2q square, it implies what? It implies that since 2q square, see, 2 times anything is even, so I'll say that it implies that, hence I would say that p square is even. Okay, so p square is even here. Okay, remember, if a square of a number is even, the number is also even. So if a square of a number is even, then the number itself is even. How come? Let us prove it by understanding. Let's say p is, if p is even, then if p is even, let us say if p is even, then I can write it as 2k. If I square it up, then what will I get? I'll get 4k square. So clearly, if p is even, then p square is even. Okay, let us prove that if that is not the case. So let's say p is odd. If p is odd, then if I square it up, so let's say if p is odd, so I can write it in terms of 2k plus 1. And if I square it up, what I'll get? I'll get 4k square plus 4k plus 1. So clearly, this 1 adds up. This is even, this will become odd. So always remember that if square is even, then number should also be even. And similarly, if square is odd, the number is also odd. Because if number is even, then its square would be even. So if remember, if a square of number is even, and I'm writing odd, then the number itself is even bracket odd. That is, if the square of a number is even, then the number, if the square of a number is even, then the number should also be even. And if the square of a number is odd, then the number should also be odd. So this is how it is. So if p square is even, it implies that p must be even. And if p is even, let's say I write it as 2 times k, where k belongs to natural, then clearly 2q square is equals to what? It will be equals to 4, I think, k square, and it will give you what? It will give you that q square is equal to 2 times k square. It implies that q square is also even. And if q square is also even, then q is even. Remember, when I was starting this particular question, I told you that if root 2 is, let's say I have to prove that root 2 is an irrational number. I started with saying that root 2 is a rational number, such that root 2 can be expressed in form of p by q, such that it is reduced to the lowest order. That is, it can be written in, that is the GCD of p and q is equal to 1. Okay, so it implies that p and q must have no common factors. Must have no common factors. So it must have no common factors. But what we ended up having, we are saying that p must be even and q must be even. It implies p and q must have a common factor of 2, because both of them are even. It implies we arrive at a contradiction that root 2 cannot be a rational. And if root 2 is not a rational number, then what it is? Then it is an irrational. Always remember that I'm going to write here. Always remember, just for, and this is something that I'm leaving for you as an exercise. We'll discuss in the next lecture. Always remember that root n is always an irrational. This is something that I'm going to discuss in the next lecture. I'm giving you it as a homework. Try to do it. So root n is an irrational number where n is a non-perfect square. So what freedom does it give to me? It gives me freedom to say that, let's say, it gives me a freedom to say, just give me a minute. It gives me a freedom to say that root over 3, root over 5, root over 7, root over 8, root over 11, root over 10. All these are what, beta? These are all irrational numbers. Okay, these are all irrational numbers. This is one thing. Now you understand one more thing. Okay, so these are irrational numbers. Now I'm going to give you another question. Let's see how many of you can follow that particular question. We have to prove, let's say, if we have to prove, let's say, what you can say about question number 2. What one can say about log 2. Is it a rational number or is it an irrational number? What it is? Okay, so let us first think about it. So how is the log graph? So I'm just plotting a graph of log. I hope everybody is in BSc, so everybody must be knowing about the graph of log 2. This is log to the base 10. So always remember the graph of log is this way. This is log x to the base a, where a is greater than 1. Okay, and this is how it is. And you see, here it is 10. So obviously this is going to be this way only. Where do we expect 2 be? So 2 would be between 10 and I can say 1. And since log here you can say is an increasing function. So clearly log is a increasing function from here you can see. Okay, so if log is an increasing function, then this is log 2 to the base 10 will lie between this. So idea you will get, so it will always lie between what beta? It will always lie between 0 and 1. Okay. So it will be positive. This is very much clear. So log 2 to the base 10 is always positive. Because this is point number 1 that you should remember. Second point that I just want to draw your attention to is how to prove the irrationality. So I have to, what can we say about the log 2? I am claiming that my claim is like log 2 to the base 10 is an irrational number. Okay, so my claim is that log 2 is an irrational number. How to start with it? So let us start with it. So in order to prove this, first I will assume, I'll go with the proof by contradiction only. And first I shall assume that log 2 to base 10 is a rational number. Let's say it is a rational number. If in case it is a rational number, what does it mean? It can be expressed in form of P by Q, where P and Q are, and obviously these are positive numbers, so I'll take P and Q to be both to be positive integers only. So I'll take both P and Q as positive integers. And clearly, since log 2 to the base 10 lies between 0 and 1, so clearly I can say that my Q would be greater than P. My Q would be greater than P. And if this is the case, then what will happen? I will write that log 10, log 2 to the base 10 is equal to P over Q. Or in other words, I can say that 10 raised to power P upon Q is equal to 2. Or in other words, 10 raised to power P is equal to 2 raised to power Q. If 10 raised to power P is equal to 2 raised to power Q, I can write 10 again into prime factors, that is 2 into 5. So what I'll get? I'll simply get 2Q minus P is equals to 5 raised to power P. Now, see, in any case, Q is a positive integer, P is a positive integer, so Q minus P is a positive integer only. Okay, so Q minus P is also positive integer. If it is a positive integer, see, on the left hand side, if anything raised to power 2, if you take, this will come out as even number. And this will come out as an odd number. So clearly, one can say that our assertion is contradicted. So therefore, it implies that log 2 to the base 10 is not a rational number, rather it is an irrational number. Okay, so these are this is how you should be proving things up. Okay, now let us do one more question, and then we'll meet in the next lecture also, so that we'll more focus on this thing. Basically, like these questions are not asked that much in examination, but you should know. You should know what are rational as well as irrational. Okay, so let us say that what can you say about ln 12 upon ln 18? Is that a rational number or is that an irrational? So whether it is a rational number or it is an irrational number. So again, the approach would be same. Let us assume that ln 12 upon ln 18 is some p over q. Always remember this is the base changing formula. This I'm just dictating you right now. I hope you know this. If you don't know this, please do understand that if you want to write log b to the base a, you can throw them to the common bases. Let's say e here. So if I'm writing ln 12 upon ln 18, so it will be equals to log of 12 to the base 18 is equals to p over q. And this I can write that 12 is equals to 18 raised to power p upon q, and 12 is equals to 18 raised to power p upon q. Then I can write that 12 ki power q is equals to 18 ki power p. And if this is the case, then I can put them in what you can say in form of factors. So this will be 4 into 3. So I will write 2 ki power 2q into 3 ki power q is equals to 3 ka square. So 3 ki power 2p into 2 ki power p. So this is how you can write. Now from this, it is very much clear that since the prime factorization is unique, so we can compare it with the powers of 2. So I can write that 2q must be equals to what? P. And it implies that q must be equal to 2p. So if you solve them up, so you know that if 2q is equals to p, if 2q is equals to p, then what I can do, I can write here instead of p 2q. So this will be, I think, dictating me that q must be 0. And if q is 0, then p must be 0. The solution from these two equations will come out as 0, 0. And if it is 0, 0, then this particular number would be 0 by 0 form, which is not the case, because I already stated that if it is a rational number, then p must belong to natural, q must belong to natural, and their GCD must be 1. They cannot be both 0 simultaneously. So therefore, we again arrive at a contradiction, and we will say that log 12 to the base e divided by log 18 to the base e is an irrational number. Okay, so all these things you should remember. You should remember means you should remember. So I'll take another class on the rational and irrational, and then we'll start with other topics as well. This particular question, if you want to know, it appeared in CMI examination, Chennai Mathematical Institute. Okay, so please to remember, such questions may be asked, such questions may not be asked. So I hope you'll be getting all these kinds of things in the coming lecture. I'm going to go all the more ahead with these topics. Till then, take care. Bye-bye.